Welcome to this session. In this video, we're going to do independent term of x, or finding the term independent of x rather. So how can you find the term independent of x in a certain expansion? So I'm going to use a question which was asked in Math 2023, Math 1120 exam to see how we can find the term independent of x in this expansion, which is x raised to the power 3, x cubed plus 2 over x, everything raised to the power 8. So how can we solve this particular kind of equation? Okay, let me write it here. So the question is x cubed plus 2 over x, everything is in parentheses, raised to the power 8. The first thing you need to write here is the formula for the binomial, okay? But in this case, we consider the formula whereby you don't have the value of r, okay? So you use the formula n combination r, then multiplied by a raised to the power n minus r, then multiplied by b raised to the power r. Let's evaluate something which we have in this kind of an expression. So we have a. Our a is just the first term, which is x to the power 3. We have our b. Our b is the second term, which is 2 over x. And we have our n. Our n is just the power, which is 8. We don't have r, okay? So let's do the substitution in this formula. So I'm going to say, since the formula is n combination r, so where there's n, we're going to substitute 8. So it will be 8 combination r. Where there's a, we'll do the substitution also. Okay. So the formula is, let me just write it here, n combination r multiplied by a n minus r multiplied by b to the power r. So n combination r, so n is 8, so 8 combination r, then multiplied by our a, in this instance is x to the power 3, then it will be n minus r, that is 8 minus r according to the formula. Then b to the power r, our b, it is 2 over x raised to the power r. So when you've been told to find the term independent of x, it means that the variable in that, or the variable attached to that certain numerical value is x to the power 0, because x to the power 0, when you have x to the power 0, the answer is just 1, okay? So that is the implication there. Let me get rid of the top part there. So what do we have? So we have 8 combination r multiplied by, I can multiply 3 throughout there, so I'm going to have x, then I'm going to say this 3 multiplied by 8, so that will be the power 24. Then again 3 multiplied by this negative r, that will be minus 3 minus 3r, then multiplied by, I can change this value which I have, which is 2 over x to the power r. According to the laws of indices, I can write this as 2 x to the power negative 1. Okay, then to the power r, I'm using the law of index, which says a to the power negative n is simply 1 over a to the power n. So this is the law I'm applying here. So what it simply means is 2, then in bracket I can have x raised to the power negative 1, then raised to the power r. Can get rid of this. So what do I have? So I have a 8 combination r, then x to the power 24 minus 3 r multiplied by 2, then 2 multiplied by x to the power negative 1 multiplied by r, it's just negative r. At this point, I'm going to ignore these two. I also ignore this n combination r. My concentration will be based on x to the power on x, where I can see x, because the point here is that I need to equate this, the variable x, to x to the power 0, so that I can know the point at which r occurs, which can give x to the power 0. Okay, so that is my goal there. So what I'm going to have is x raised to the power 24 minus 3r multiplied by x raised to the power negative r being equal to x to the power 0. Let me get rid of the top part there. Then I can find the value of r, whereby I'll use the law of index, which says when you're multiplying the same bases, you just add the power. So it will be x raised to the power 24 minus 3r, then plus negative r is equal to x to the power 0. So what I have is x to the power 24 minus 3r, positive multiplied by negative is just negative r, equal to x to the power 0. So what I'm going to have is x 24 negative 3 minus r, that is just minus 4r, is equal to x to the power 0. Then I can find the value of r. Since the bases are the same, it means that even the powers 24 minus 4r is equal to 0. I can take this 4 to the other side, so I'll have 4r is equal to 24. I can now evaluate the value of r. Since I have 4r is equal to 24, I can say over 4 there, even there over 4. 24 divided by 4, that should give r is equal to 6. I've now evaluated the value of r, so I can go back now to the formula and substitute at the point where I didn't have the value of r, where there was r. So it was 8 combination r our a was x raised to the power 3, then this was n to the power n minus r, so it was 8 minus r. Then our b was 2 over x to the power, that is to the power r. R was r we found now. We found the value of r, so it will be 8 combination. Our r is 6, so substitute 6 there. Then multiplied by x here we're going to have x to the power 3, then 8 minus our r is 6, then here we're going to have 2 over x, our r is 6. Let me get rid of the top part. So what I'm going to have is 8 combination 6, then I'm going to have multiplied by x to the power 8 minus 6, that is 2, 2 times 3, that is 6, so it will be x to the power 6 there, then multiplied by 2 to the power 6, then over x to the power 6. Just distributed this power. Okay, so you can see that x to the power 6 can cancel with that x to the power 6. This is on the denominator, that is on the numerator. So I'm going to have 8 combination 6 multiplied by 2 to the power 6. So that will give 8 combination 6, that is saying 8 factorial. For combination, we use the formula n. So when you have n combination r, this is simply n factorial over n minus r factorial, then multiplied by r factorial. So this is what I'm going to use here. So I'm going to say 8 factorial over 6 minus our r is 6, 8 minus 6 factorial, then our r again 6 factorial. Then this is being multiplied by 2 to the power 6. Okay? So this is what I'm going to do at this point. So what do I have there? I can do something with x 8 combination r. So that is 2 there. Okay, so what I'm going to have 8 combination r, 8 factorial, I mean that is 8 multiplied by 7. I'll end on 6 because I have 6 factorial there, so I'll end on 6 factorial so that it will cancel with what I have on the denominator. So 8 minus 6, that is a 2 factorial multiplied by a 6 factorial, then everything multiplied by 2 to the power 6. 2 to the power 6 is 2 multiplied by, okay, so I can just say 2 to the power 5 is 32. Okay, then multiplied by, then 2 to the power 6 will now be 32 times 2, so that is 64. So multiplied by 64 there. I've evaluated 2 to the power 6. So this is what I have. At this point, I can cancel 6 factorial and 6 factorial. 2 factorial is just saying 2 times 1. So 2 times 1 is just 1. So 2 factorial can go into 8 to give 4. So what I have is 4 multiplied by 7. I don't have anything on the denominator. Then multiplied by 64. 4 multiplied by 7, that is 28. Then multiplied by 64. What is the answer? So let's work it out here. So 64 multiplied by 28. So 8 by 4 by 8, that is 32. So 2 remainder 3. 6 times 8, that is 48 plus 3. That should be 51. 2 times 4, that is 8. 2 times 6, that is 12. So 12 there. So I'll have 2 there. I'll have 9 there. I'll have 5 plus 2, that is 7 there. And 1 there. Okay. So the answer is, it is giving is 1792. Let me just write it properly. So it's 1792. 1792. So this is our answer. So if you found this helpful, Don't forget to share, subscribe, so that you are notified each time I upload a new video like this. Then also comment and like the video if you found it to be helpful. Thank you for watching.